That's known as conservation of charge. That's known as conservation of charge. Law of conservation of charge, we can say. It's the law of conservation of charge. What does law of conservation of charge state? It states that charge can neither be created nor be destroyed, but charge can neither be created nor be destroyed. However, if it gets created or destroyed, it always creates or destroys in pairs. That means चार्ज ना कभी क्रिएट हो सकता है ना कभी डिस्ट्रॉय हो सकता है। अलबत्ता अगर अब ये कभी क्रिएट हुआ या कभी डिस्ट्रॉय हुआ, ये हमेशा क्रिएट होता है पेयर्स में या हमेशा डिस्ट्रॉय होता है पेयर्स। क्लियर? नाउ वी विल टेक एन एग्जांपल. फॉर एग्जांपल, इट इज न्यूट्रॉन. इट्स न्यूट्रल. इट इज न्यूट्रल. Suppose this neutron collides with the atoms of the atmosphere. It gains energy. It becomes unstable. When it becomes unstable, it splits into an electron and a proton. Now, what is the charge of electron? It's minus 1.6 into 10 to the power minus 19 coulomb. And what is the charge of proton? It's plus 1.6 into 10 to the power minus 19 coulomb. That means two equal and opposite charges are produced on the dissociation of a neutron. Here again the net charge will be equal to 0. Therefore charge remains conserved. Clear? This is an example of pair production. This is an example of pair production. A pair gets created. And this obeys the law of conservation of charge. This obeys the law of conservation of a pair is created. यहाँ पे एक पेयर क्रिएट होता है, एक इलेक्ट्रॉन और एक प्रोटॉन क्रिएट होता है. दोनों का चार्ज इक्वल और अपोजिट होता है और दोनों का नेट चार्ज क्या बन जाएगा? 0. और न्यूट्रॉन का भी चार्ज क्या होता है? 0. Here charge gets created, but it always gets created in a pair, and the total charge remains conserved. Clear? This is pair production. Now, if we take an example of a gamma ray photon, or we take example of an electron and a positron. When they combine together each other, they form two gamma ray photons. That means two charges gets destroyed in a pair. And two gamma ray photons are produced, having 0 charge. Now, an electron and a positron, they have net charge equal to 0. And again, the net charge produced is equal to 0. So, two charges are destroyed. But they get destroyed in pairs. And net charge again remains conserved. Clear? समझ आया? Now, if one gamma ray photon gets destroyed, it makes an electron, or it produces an electron and a positron. Here only one gamma ray photon produces one electron and one positron. But when a pair, an electron and a positron gets destroyed, they form two gamma ray photons. Why so? This is known as matter annihilation. Why matter annihilates in this case? It is because to conserve momentum and energy. अगर एक गामा रे फोटॉन डिसोसिएट हो जाता है और ये बनाता है एक इलेक्ट्रॉन और एक पॉजिट्रॉन, ऐसा क्यों होता है? क्योंकि जब ये गामा रे फोटॉन कोलाइड करता है, it gains energy. When it gains energy of 1.2 million electron volt, it becomes unstable. So after becoming unstable, in order to gain stability, it gets dissociated into two charges, that's an electron and a positron. However, when an electron and a positron gets destroyed, instead of one gamma ray photon, two gamma ray photons are produced. ऐसा क्यों होता है? अगर फिर से एक ही गामा रे फोटॉन बन जाता 1.2 मिलियन इलेक्ट्रॉन वोल्ट का, वो फिर से स्टेबल होता, अनस्टेबल होता, वो फिर से. सो इन ऑर्डर टू गेन स्टेबिलिटी, यहाँ पे दो गामा रे फोटॉन्स प्रोड्यूस हो जाते हैं, ईच ऑफ एनर्जी 0.51 मिलियन इलेक्ट्रॉन वोल्ट. हर एक गामा रे फोटॉन की एनर्जी कितनी होती है? 0.51 मिलियन इलेक्ट्रॉन वोल्ट. और टोटल एनर्जी फिर से बन जाती है, इट इज इन फैक्ट 1.02 मिलियन इलेक्ट्रॉन वोल्ट. और टोटल एनर्जी फिर से रह जाती है 1.02 मिलियन इलेक्ट्रॉन वोल्ट. So in order to conserve energy and also in order to conserve momentum, instead of 1, 2 gamma ray photons. 2 gamma ray photons are. This is the law of conservation of energy. Law of conservation of charge. Clear? Now we will move to a new concept. We will make a comparison. We will draw a comparison between charge and mass. We will draw a comparison between charge and mass. What is mass? It is a quantity of matter present in a substance. Mass is defined as a quantity of matter present in a substance. It is quantity of matter. It is quantity of matter present in a substance. Present in a substance. And what is charge? It's the intrinsic property of a substance by virtue of which it attracts or repels another kind of charge. Attracts or repels another kind of charge. This mass is the fundamental quantity. This charge is also a fundamental quantity. In case of comparison, we take both similarities as well as dissimilarities. This mass is measured in kg. Its SI unit is kg. And this charge is measured in coulomb. Its SI unit is. Clear? This mass is invariant with this charge is invariant with speed. This charge is invariant with speed. That means if the speed of a body changes, its charge remains constant. Its charge does not change. However, if the speed of mass changes, if the speed of body changes, its mass also changes. Its mass also, according to mass dilation concept given by Einstein. According to mass dilation concept given by, suppose m naught is the rest mass of a body or rest mass of a particle. If m naught is the rest mass of a particle, rest mass means when the particle will be at rest, it's not moving. And m is the mass of the particle when it is moving. M is the mass of the particle when it is mass of moving particle. Mass of moving particle. Now, if particle is moving with speed v, then according to Einstein, its mass will be equal to, its mass changes according to equation m naught upon root 1 minus v square upon. Now if v increases, this term v square by c square also increases. More the term v square by c square increases, lesser the term 1 minus v square by c square becomes. जितना v square by c square ज्यादा बढ़ जाएगा, उतना 1 को हमें ज्यादा माइनस करना पड़ेगा. जितना ज्यादा माइनस करना पड़ेगा, उतनी डिनोमिनेटर वाली टर्म कम हो जाएगी, उतनी ये टर्म डिक्रीज हो जाएगी, और जितनी ये टर्म डिक्रीज हो जाएगी, उतना ये मास पार्टिकल का इंक्रीज हो जाएगा. Therefore we can say, on increasing the speed of a body, its mass also increases. This is known as mass dilation concept given by Albert Einstein. However, the charge does not change. The charge of a body does not, unchanging it is speed. Clear? This is most important point here. Mass of a body changes, with change in its speed. However, the charge remains constant. It does not change with changing the speed. Clear? Now we will move to one more point that is known as, it's in fact another concept that's known as Colombus law. Now we will discuss Colombus law. In electrostatics. Colombus law in electrostatics. First point which you have to remember is that Colombus law is applicable only to static charges. It's not applicable on moving charges. Now, what does Colombus law state? It states that the force of interaction, the force of interaction means either attraction or repulsion between 2 point charges. The force of interaction between 2 point charges is directly proportional to the magnitude of these two charges and inversely proportional to the square of distances between them. Inversely proportional to the square of distances between them. Suppose we have 2 point charges, say charge Q1 and charge Q2, separated by distance say R. Separated by distance. Then according to Colombus law, the force of interaction between these two charges is directly proportional to the product of magnitude of these two charges. Is directly proportional to the product of magnitude of these two and is inversely proportional to the square of distances between them. And is inversely proportional to the square of distances between. Therefore, we can write F is directly proportional to Q1, Q2 upon R square. Which implies we can write F is equal to, here we can make use of constant of proportionality, and the constant of proportionality usually in this case is K. Therefore we can write F is equal to K Q1 Q2 upon R square. This constant of proportionality K, it is known as electrostatic force constant. It is known as electrostatic force constant. It is known as electrostatic force. Now what is the value of K? What is the value of K? Likewise, G का value हम लेते हैं 6.67 into 10 raised power minus 11 Newton meter square per kg square, calculated by Henry Cavendish. जो Henry Cavendish ने निकाला है using his sensitive balance, and it is the experimental value of G. But unlike G, the value of K depends upon two things. The value of K depends upon the system of units used and also the medium between the two charges. जो K का वैल्यू होता है ये दो चीजों पर डिपेंड करता है. एक ये डिपेंड करता है हम किस सिस्टम में इसका वैल्यू लेंगे. हम सीजीएस सिस्टम में इसका वैल्यू लेंगे, हम एसआई सिस्टम में इसका वैल्यू लेंगे, और ये डिपेंड करता है इन दो चार्ज के बीच में मीडियम क्या है, उस पर भी ये डिपेंड करता है. समझ आया बेटा? नाउ इन केस ऑफ सीजीएस सिस्टम एंड द मीडियम बिटवीन द टू चार्जेस विल बी एयर और वैक्यूम. जब सीजीएस सिस्टम की बात करेंगे हम, इन सीजीएस सिस्टम और जो मीडियम हम लेंगे इन दो चार्जेस के बीच में, वो हम या एयर लेंगे या वो वैक्यूम होगा. देन द वैल्यू ऑफ K इज फाउंड टू बी 1. अब इसका वैल्यू कितना होता है? 1. यानी सीजीएस सिस्टम में और मीडियम होगा चार्जेस के बीच में एयर या वैक्यूम, K का वैल्यू कितना होता है बेटा? 1. Therefore we can write in CGS system F is simply equal to K के बदले 1, it will be simply equal to Q1 Q2 upon R square. यहाँ पे हम चार्ज कॉलम में लेंगे, R सेंटीमीटर में लेंगे, और फोर्स जो हमें निकलेगा it will be in time. CGS unit of the force. Clear? Now in case of SI system, and again the medium between the two charges is air or vacuum. अब SI system की जब हम बात करेंगे, और जो मीडियम हम दो चार्जेस के बीच में लेंगे वो हम फिर से लेंगे एयर या वैक्यूम. इन SI system the value of K is equal to 1 upon 4 pi epsilon naught. The value of K is equal to 1 upon 4 pi epsilon. What is this epsilon naught? This epsilon naught is known as absolute permittivity of the free space. It is known as absolute permittivity of the free space. What is absolute permittivity? The absolute permittivity of the free space means how much the space allows the two charges to interact. Space कितना allow करेगी दो charges को interact करने में? That's known as absolute permittivity. That's known as just absolute permittivity. The value of this epsilon naught is 8.85 into 10 raised power minus 12 coulomb square per Newton. एप्सिलॉन नॉट का समझ आया? जब एप्सिलॉन नॉट का वैल्यू हम इस इक्वेशन में सब्स्टिट्यूट करते हैं तो K का वैल्यू कितना हमें मिलता है? इट इज 9 into 10 raised power 9 न्यूटन मीटर स्क्वायर पर कूलम. ये आता है हमें SI सिस्टम में K का वैल्यू 9 into 10 raised power 9 न्यूटन मीटर स्क्वायर पर कूलम. Therefore we can write in case of SI system F is equal to K के बदले 9 into 10 raised power 9 Q1 Q2 upon R square. Or we can also write like this: F is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R. This is Coulomb's law in SI. Clear? Now we have to discuss the units and dimensions of this K. The units and dimensions of and also of epsilon naught. And epsilon naught और K के units क्या होते हैं? Units and dimensions of K. Units and dimensions of we know F is equal to K Q1 Q2 upon R square. From this equation we can write FR square. R यहाँ से डिवाइड है R square, यहाँ से मल्टीपल हो जाएगा. Q1 Q2 यहाँ से मल्टीपल है, यहाँ से डिवाइड हो जाएगा. So we can write Q1 equal to or we can also write K is equal to FR square upon Q1 Q2. Now the unit of force is Newton. The unit of distance is meter. So we can write meter square upon the unit of charge is coulomb. We can write coulomb into coulomb. That is coulomb. This is the unit of. We can also find its dimensions here. The dimensions of force. The dimensions of force are M1, L1, T raised power minus 2. The dimensions of R are L. So we can write L square here. This is R square. Upon the dimensions of charge are AT. The dimensions of charge are AT. So we can write AT into A. Now we can write it's equal to M1 L1 into L2. It is L3. T raised power minus 2 upon A into A. It's A square and T into T is T. It will be equal to M1 L3. T raised power minus 2. डिनोमिनेटर में 2 है तो minus 2 फिर से हो जाएगा तो ये बन जाएगा T raised power minus 4. A square ऊपर जाएगा तो A raised power minus 2. These are the dimensions of. Clear? Now epsilon naught. The units or dimensions. We know K is equal to 1 upon 4 pi epsilon naught. Here K is inversely proportional to epsilon naught. Here K is inversely proportional to. So the units of epsilon naught will be inverse of K. Therefore we can write epsilon naught के units coulomb square per Newton meter square. यानी इसका उल्टा करना है. And its dimensions. M1 के बदले m raised power minus 1. L3 के बदले L raised power minus 3. T raised power minus 4 के बदले T raised power 4. और A raised power minus 2 के बदले A2. These will be the dimensions of epsilon. Clear? चीजें समझ आया? Now we will discuss one more topic, that is dielectric constant. That is dielectric constant. Again we make use of Colombus. In vacuum or air, F is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R. This is the equation. Now, if we take two charges in any other medium, any other medium having dielectric constant, having say permittivity epsilon. परमिटिविटी हम कितनी लेंगे बेटा? एप्सिलॉन. समझ आया? Therefore in case of medium, अगर हम दो चार्जेस लेंगे किसी दूसरे मीडियम में और उसका जो परमिटिविटी हम लेंगे ना, परमिटिविटी ऑफ मीडियम, वो हम एप्सिलॉन m से डिनोट करेंगे. Therefore we can say force in any medium between the two charges, it will be equal to 1 upon 4 pi epsilon m q1 q2 upon r. This is the equation. This is force in air. Let it be denoted by f naught. हम किसे denote करेंगे? Now divide first by second. Divide first by what we will get? F naught upon fm. F naught upon fm will be equal to, ये 1 upon 4 by 1 upon 4 by cancel हो जाएगा आपस में, तो यहाँ पे आएगा epsilon m divided by epsilon naught. It will be epsilon m divided by epsilon naught. ये q1 q2 divided by r square, q1 q2 divided by r square, ये भी cancel हो जाएगा. Taking reciprocal, we can write fm upon f naught will be equal to epsilon naught divided by epsilon. समझ आया? यहाँ तक क्लियर हुआ ना? कहीं पे कंफ्यूजन तो नहीं है ना? This ratio, this epsilon m upon epsilon naught, it is represented as epsilon r. It is represented as epsilon. So what is this epsilon m upon epsilon naught? It is the relative permittivity of the medium. It is the relative permittivity of the means the permittivity of the medium with respect to the air. Permittivity of the medium with respect to, जैसे आपने relative refractive index पढ़ा है. Relative refractive index में हम क्या बोलते हैं? Relative refractive index में हम बोलते हैं refractive index of one medium with respect to the another medium. और absolute refractive index में हम बोलते हैं refractive index of one medium with respect to the air. Same is the case here. The absolute permittivity of medium with respect to air, or we can say the ratio of absolute permittivity of medium to the absolute permittivity of air is known as relative permittivity of the medium. This relative permittivity of the medium is known as dielectric constant of the medium. It's also denoted by K. So this dielectric constant is also denoted by K. Clear? So how we can define the dielectric constant of a medium? It is defined as the ratio of permittivity of the medium to the permittivity of air. It is also defined as the ratio of force between two charges in air to the force between same two charges separated by same distance in any other medium. Clear? Clear one? Now, for example, the dielectric constant of water, Kw, denoted by K, it is 81. It is the dielectric constant of the water. Clear? Now, this dielectric constant of a medium also depends upon the temperature. It also depends upon the temperature. That means the dielectric constant of the medium changes with change in its temperature. Changes with change in its temperature. As the temperature of the medium changes, dielectric constant also changes. If the temperature of the medium increases, it is dielectric constant decreases. It is dielectric constant and vice versa. For example, this Kw is the dielectric constant of the medium at 20 degrees Celsius. At 20 degrees Celsius. And same water has dielectric constant 78.5 at 25 degrees Celsius. That means this dielectric constant of the medium changes